Hi, in today's video, we're going to talk about linear inequalities or linear inequations. I want to give you a quick example of what that means. Let's say we have 2 is less than, let's pick a number, let's pick 6. 2 less than 6, this is an inequality, anything that's not an equation. The left side is not equal to the right side. 2 is less than 6, so it's called an inequality. Less than or equal to, this is the general symbols for inequalities. That's the greater than sign, greater than or equal to, and you have not equal to. I just want to say that you can read this inequality in two different ways. You can read that as 2 less than 6. You can also read that if you are reading starting from the right side towards the left side. If you're reading it backwards, you can read it as 6 greater than 2. So this is true if you're reading it from the left side to the right side. Okay, so this is true if you're starting from the right side and you're reading towards the left side. So what that just means is, if you have an inequality like that, and if you flip the sides of the numbers, if 6 goes first and 2 comes next, what do you do with the inequality in between? The less than will have to flip and turn around like that. Then only it'll be true. That's one of the rules. People get confused with that sometimes, so I just thought it would be good to say that. The other rules are what happens to an inequality when you add, subtract, multiply, or divide another number to it. So let's do some very quick examples. I'm just going to use the first inequality that we used over here. We have 2 less than 6. What's going to happen to this inequality? Let's say if I'm going to be adding 1 on both sides. So when I add 1 here and when I add 1 here, it just becomes 3 on the left side and 7 on the right side, and the inequality remains true. 3 is still less than 7. So it doesn't really change. Addition doesn't really change an inequality. What if you subtracted 1 on both sides of that inequality? So you have 2 less than 6. If you took away 1 from both sides, 2 minus 1 is just 1. 6 minus 1 is 5. And this inequality is still true. 1 is still less than 5. So subtraction also did not change the inequality. Addition and subtraction does not change the inequality. Now, what happens when you multiply or divide? Okay, so let's say we're going to multiply by 2 on both sides. Okay, so I'm going to multiply here by 2 times 2, and I'm going to multiply the right side by 2. So we get 4 less than 6 times 2 is 12. So when I multiply it by a positive number on both sides of the inequality remained true. It didn't really change it. But what happens if I'm going to multiply by a negative number on both sides of this inequality? So let's say I multiplied here by -2, and I multiply the right side also by -2. Here we get 2 times -2 is -4. And here we get 6 times -2 is -12. Now is this inequality true? If I write -4 is less than -12, is that true? So we know that on the number line, we have 0 here, we have -4 somewhere here, and -12 comes somewhere over there. And we know that on the number line, numbers on the right side are greater than numbers on the left side. So here, this is the only inequality that can be true. We know that -12 is less than -4. So here it says that -12, if you start reading from -12, it's greater than -4, which is false. This is false, not true. So what we need to do is, when you multiply with a negative number, always remember to flip the inequality, then only it will remain true. So -4 is greater than -12. Okay? So whenever you multiply, multiplication actually changed the inequality of a negative number. Negative number. Okay, the same happens when you also divide by a negative number. Same thing will happen. The inequalities will have to be reversed, otherwise it won't be true. Let me show you a very quick example. Maybe here itself you had 2 less than 6. Let's try to divide by -2 on both sides. Okay, so dividing by -2, dividing by -2, on this side we will get -1, on this side we will get -3. And we know that -1 is not less than -3, it has to be greater. So to flip, You have to flip or change the inequality. So this is only when you are multiplying or dividing by a negative, you have to change the inequality. Okay. So those are some of the main rules involved in solving linear inequalities. Let's do some problems now. The first problem here is to solve and graph the solution set of this inequality. So you would treat this just like a regular equation. How would you solve this if this was a regular equation? That's exactly how you solve an inequality first. So you subtract 4 on both sides. You cancel 4, you get 3x is less than 12, and then you divide by positive 3 on both sides, so you get x less than 4. That's your solution. Okay. Now there are two things I want to talk about the solution set. Here the solution is all the x which is less than 4. That means if you think about a number line, you have 0 somewhere in the middle and you have the number 4 to the right side. So x less than 4 just means that all the numbers without including 4, all the numbers that are less than 4. That's infinite numbers. You go all the way from 4, 3, 2, 1, 0, all the decimals numbers in between and everything, and all the negative numbers. So it's like a big set. So this is the general solution. Okay, the general solution, I'm just going to put GS for general solution. The general solution is the set of all x such that x is less than 4. So how would you graph it? You would put an open circle above 4. That means you cannot include 4, but all the numbers less than 4. So you put a graph to an arrow to the left side. Sometimes you have a restriction on the domain. That means you don't need to give me all the values, all the solutions. You just have to give me solutions that satisfy certain conditions. So that condition or that set is called the replacement set. Okay, I'm just going to use the letters RS. For example, I could have a condition on the domain and I could call the replacement set as the set of natural numbers. Okay, so X has to be the set of natural numbers. So then your solution set, I'm just going to put SS for solution set, will be from this general solution, I'm only going to take the set of natural numbers. So here we know natural numbers starts from 1. Natural numbers is a set of numbers that starts from 1 and it goes on for infinity, right? So what do you have in common with the solution set and the set of natural numbers? We have 1, 2, 3, and 4. So I cannot take any numbers which are less than any of the negative numbers over here. Okay, any of the numbers that aren't in this set cannot be in the solution set. So the solution set will be 1, 2, and 3. I cannot include 4 because it's an open circle here, so I cannot include 4. So in this question, if the replacement set is a set of x such that x belongs to the natural numbers, then the solution set will be not an infinite set, a finite set. The solution set was an infinite set. It was a set of all x such that x is less than 4. That was supposed to be an infinite set. But now, since there's a condition or a restriction on the domain saying that x has to be the set of natural numbers only, so from this general solution set, I was choosing and picking the numbers that only satisfied the condition over here. So let's do another example. 15 minus 3x greater than x minus 3. Same thing we're going to solve and graph here. So when you have x on both sides of the equation, what you need to do is bring all the variables on one side and the constants on the other. It's better to bring the variables on the left side because it's easier to work that way. So let's do minus x and minus x on both sides. So we will get negative 4x and you have this sign over there. And then I'm going to cancel the positive 15. I'm going to do minus 15 here and minus 15 under this number. So they can combine and this will become negative 18. To solve for x, we have to now divide by negative 4 on both sides, right? Remember, when you divide by a negative number, you have to switch the inequality. The greater than sign becomes less than. Negative 4 will cancel. I will get x less than. They will cancel. I'll get 4.5. So this is again, and this is a general solution. General solution is a set of all x. The only condition is x must be less than 4.5. So if this is a number line and 4.5 is right there, I cannot include 4.5. It'll be all the numbers below 4.5. Now, how would this be different? How would this problem be any different if you had a sign like that, a greater than or equal to sign? So that would be over here. So when I flip it, it would just be less than or equal to. When I graph it, it will be a shaded circle instead of an open circle. That's the only difference. Okay. Now let's say for this new question that we just made up, let's say there is a replacement set. And the replacement set is the set of integers. The set of integers that are positive. Okay. So here we know our answers is like an infinite set. We start from 4.5, including 4.5. We have all the numbers below it as an answers. So that means we can go to 0 and we can go beyond 0. That's the general solution. But now we have a restriction, right? The restriction or the replacement set is given to be integers that are only positive. So the numbers that you can take are integers like 4, 3, 2, 1, and 0, and no negative numbers. Okay. So the solution set will be set of 0, 1, 2, 3, and 4, because they're supposed to be integers and they're supposed to be positive. I can't take any of the negatives and I can't take any of the decimals because they're integers. Another question. Here is one which has an inequality and one more inequality connected. There's 3 parts to it. So how do we do this? So we can see this, we can write this as 2 separate inequalities first. 2y minus 3 less than y plus 1. So I combine these two together to write my first inequality. And then what I'm going to do is I'm going to combine these two together to write my second inequality. Y plus 1 less than or equal to 4y plus 7. Then we solve each one separately. I want to bring all the y on the same side, so I subtract y on both sides. And then I bring the numbers on the other side, so I do that. So y and y cancels. 2y minus 1y will become y. Negative 3 positive 3 cancels. 1 plus 3 is 4. So I got my solution to the left side. Subtract 1, subtract 1, subtract 4y, subtract 4y. I get negative 3y less than or equal to 6. When I divide by negative 3 on both sides, since I'm dividing by a negative, I'm going to flip the inequality and I get negative 2. So we're talking about y. We have 2 conditions on it. Y has to be less than 4, and y has to be greater than negative 2. So greater than or equal to negative 2. So how do we graph it? On the number line, we have 4 on the right side and negative 2 on the left side. Since y is greater than or equal to negative 2, we include the negative 2, and since it's only less than, no equal to, we put an open circle, and we have graphed that. So I want to call this video as part 1, and I want to do one more question in the second part of this video, as a second part to this video, because I think I can do one more problem with the fractions in it that can help you more. So look out for part 2 of this video.